performing strength exercises, it is important to differentiate between two main angles, the angle of the joint and the angle between the weight and the moving organ. Every movement at the joint has only one optimum angle. The optimum angle is the maximum strength at that joint. For example, at the shoulder joint, in an abduction movement, the shoulder abductors develop their maximum strength at an angle of 180 degrees, or when the arm is next to the body, the shoulder abductors are strongest. In the remaining angles of this movement, this group of muscles is significantly weaker. In addition to the angle of the joint, attention needs to be paid to the angle between the weights and the arm. In this state, the weight creates a rotating component and places a burden on the shoulder muscles. However, when the arm is next to the body, the weight does not cause rotation of the arm, meaning no load is being transferred to the lateral deltoid. In terms of the angle at the shoulder abductors are strongest next to the body. However, the weight does not place a burden on these muscles, meaning the weight does not cause rotation on the arm around the shoulder axis, meaning no load transferred to the lateral deltoid. Meaning, in this state, the shoulder abductors are not being exerted upon at all. So how could you create a rotational movement that will place a load on the shoulder abductors at which angle when they are strongest? You simply turn your body and lie on your side. This will create a state where the weight is perpendicular to the arm and will place a load on the shoulder abductors. In this state, the angle at the joint is optimal, and the angle between the weight and the arm is 90 degrees.
Now, to illustrate the point, let's look at some different variations of the lateral raise. In this first variation, it is simple abduction in the frontal plane. In this second variation, it's an abduction in the scapular plane, but 30 degrees forward. When you compare them side by side, you can clearly see the angles involved. The frontal plane abduction and the scapular plane abduction look very different. Shoulder abduction in the frontal plane is not a natural movement. Abducting the shoulder in the scapular plane, about 30 degrees interior to the frontal plane, is a much more natural movement which does not cause any shoulder impingement. In this scapular plane, impingement will always be avoided. In the third variation, this will be abduction with a slight external rotation. Here you can see in the upper portion with external rotation or shoulder external rotation, and in the bottom without the external rotation. Here we can see the abduction without the external rotation. The subacromial space narrows, and the common tendency to impinge the tendon, or bursa, can cause an inflammatory response. The classic sign of the supraspinatus tenderness is the painful arc on the resisted abduction between 60 and 120 degrees. This happens during external rotation. External rotation allows the greater tubercle to pass posterior to the upper con, avoiding potential impingement. So if you feel pain during the lateral raise, keep your arm in a slightly externally rotated position, which means the dumbbell should be horizontally turned up to reduce the potential shoulder problem. However, this does not mean it's a good movement, simply that it'll eliminate this particular problem. Now in the fourth variation, abduction in the frontal plane with bent elbows, you can clearly see the effects of a straight arm versus a bent arm. Quite possible to double the weight and have the same exact load delivered to the muscle. This is due to lever magnification. Now here we can see a common mistake and a common compensation. This will be the variation 5, bent elbows with external rotation. This is very common among young lifters who want to lift too heavy of weights. This, of course, is a shortened range of motion in the shoulder, and the dumbbell is high because of the shoulder external rotation, meaning the compensation of it. Here you can see how the entire body is used, momentum generating, as well as lifting the dumbbells high, forcing the upper arm to remain low. This will be the final variation, bent elbows with external rotation and spinal extension. Now this highly loads the back and of course removes or subtracts the weight from the lateral deltoids. Now let's talk about following exercises inside the resistance curve. There will be a large difference when using a cable, even if weighted the same as the dumbbell, when performing a standard lateral deltoid raise. It is very important to understand that angles as well as lever magnification play a critical role in exercise selection, as well as where gravity comes from. At an angle perpendicular to gravity, the lateral deltoid will receive 100% of the load, and in the case of the dumbbell, this is at the fully contracted position. However, this is where the muscle is the weakest in the resistance curve, due to the muscle being in a fully contracted position. However, when working against a low cable resistance, the resistance curve is optimized at the beginning of the movement, as the lateral deltoid is strongest here, and at the conclusion, weakest or receives the least load from the pulley. This is optimum, as in the fully contracted position, it will only be receiving 50% of the load, and at the beginning portion of the movement where the muscle is strongest, it will be receiving 100% of the load inside of the correct resistance curve. Now, this has already been previously addressed in the case of the dumbbell. When it is parallel with gravity, or naturally resting against your side, there is no load whatsoever on the lateral deltoid. Here you can see the lateral deltoid using the low cable attachment passing through the correct resistance curve and what the load looks like actually being delivered to the muscle. And in this example, you can see how it would compare to using a dumbbell outside the correct resistance curve. An alternative, as has already been previously addressed, is you'd be using a dumbbell. You should perform this exercise lying on your side and following the same pathway, as this will load the muscle identically to performing a standard lateral cable raise.